Hello everyone, I am Noor Zainab, and in this video we are going to derive the first equation of motion, and we will also discuss that how this first equation is converted into the free fall motion equation. So let's get started. Basically there are three equations of motion in physics. These equations relate final velocity, initial velocity, displacement, time and acceleration. Here Vf defines the final velocity and Vi defines the initial velocity of the object. Vi, or the initial velocity of the object, can also be represented by u. So in this video we're going to discuss about the first equation of motion, how to derive it, and in the upcoming videos I will discuss the next equations of motion. So let's consider a car. The velocity with which it is moving at time t, which is equals to 0, that velocity is known as the initial velocity of the car. This can be 0 or it can be moving at any velocity like 10 meter per second or 20 meter per second. So we can say that the velocity of an object at time t is equals to 0 is known as the initial velocity of the object. After time t, the velocity of the object becomes final velocity, which is represented by Vf. An object is said to be accelerated only if there is a change in its velocity. So here comes the definition of acceleration. This change of velocity with time t is known as acceleration. The rate at which an object is changing its velocity with respect to time is known as acceleration, and this acceleration's formula is delta v over t. Delta v represents the change in velocity, which is equals to the final velocity minus the initial velocity of the object divided by time t, the time during which the velocity is changed. All the three equations of motion which we are going to discuss are built on the basis of constant acceleration. Constant acceleration is when the velocity of the object changes by the same amount every second. For example, let's suppose that at time t is equals to 0, the velocity of the object is 0 meters per second, but after time t, the velocity becomes 4. After time 2 seconds, the velocity becomes 8 meter per second. As now we can see that the change in velocity, which is known as acceleration, is constant, which is 4 meter per second square. The velocity is changing by the same amount, it is 4 in every second. So this is known as constant acceleration, also sometimes referred as uniform acceleration. Now here you can see a graph. The x-axis of the graph is showing time t and the y-axis is showing the velocity v. After plotting the values of the velocity on y-axis and the time on x-axis, we are getting a straight line. In order to calculate the slope of this graph, we have to divide the vertical component of this graph by its horizontal component. The vertical component of this graph is giving us velocity, whereas the horizontal component of this graph is giving us time t. So our slope becomes velocity divided by time t, and the change in velocity divided by time t is known as acceleration. And however, when we calculate the area of this same graph, what happens is that we have to multiply the vertical axis and the horizontal axis. We have to multiply the vertical axis velocity into the horizontal axis time t. What we get is v into t, which is equals to displacement s. Displacement is the shortest distance between 2 points. So we can say that the slope of velocity time graph gives us acceleration, whereas the area of the velocity time graph gives us displacement. So now let's see the graph of a body which is moving with constant acceleration. Its initial velocity is v is equals to 0 and its final velocity is vf. Because the body is moving with constant acceleration, the graph will be a straight line. The initial velocity of the body is 0, whereas the final velocity is Vf. So this is a graph of a body whose initial velocity is 0. But now let's discuss the graph of a body which is not having initial velocity 0. Its initial velocity is Vi. It means that the body is moving with certain velocity which is Vi. The initial velocity is Vi and it is not equal to 0. And the final velocity of the body is Vf. After some time t, the velocity of the body changed from Vi to Vf, and during this time period, the acceleration of the body was produced. That we can say that the body had accelerated. So if we plot the graph of this body, whose initial velocity is Vi and the final velocity is Vf, it will look something like this. The vertical axis is showing us velocity, whereas the horizontal x-axis is showing us time t. The initial velocity is Vi. It is not equal to 0. It is somewhere any value in the velocity axis. And the final velocity is Vf. After some time t, the velocity of the object is becoming Vf, which is the final velocity. So now if we plot the vertical axis, the Vf time, and the horizontal axis, what we get after naming with some alphabets, the initial velocity is named as a. We are naming the slope as ab, and the initial velocity is known as ac, whereas you can see that AD line segment shows us the time during which the body has accelerated. BC is the change in velocity and AB is the slope itself. So if now we have to calculate the slope of this graph, the graph whose initial velocity is not 0 but it is Vi. How we can calculate the slope of this graph? The slope of this graph is AB. The slope of the graph is equals to change in velocity divided by time t. As we know that the change in velocity is a final velocity minus initial velocity, and it gives us acceleration. And this acceleration is always constant in the equations of motion. It's constant, it means that its value is always same. So if we calculate the slope of this particular graph, how can we calculate it? The slope of line AB is equals to the vertical component divided by horizontal component. In this case, the vertical component is named as BC and the horizontal component is named as AC. This is the slope, and the vertical component of the slope is this, which is BC, and the horizontal component is named as AC. Now we will do some mathematical operations, as we are seeing that BD is divided in two parts. One part is BC and one part is CD. So we can say that BD is giving us two components, BC and CD. So we can convert BC into BD minus CD. It means that BD is a complete line. If we remove CD from this part, what we will get BC, and we need it because it is the part of the slope's vertical component. So we can write BC is equals to BD minus CD. BD is the full line. We don't need the full complete line. So we will remove CD. What we will get is BC line, which is the part of our slope. So by putting the value of BC in the above equation of acceleration, we get this equation. If we look closely at the graph, we can see that that BD is giving us final velocity, which is Vf, whereas CD is giving us initial velocity, which is Vi. So we can replace BD by final velocity Vf, and we can replace CD with initial velocity, which is Vi. Also, we are seeing in this graph that AC line segment is showing us time t during which the body has accelerated. By saying accelerated, I mean that the body has changed its velocity from Vi to Vf. So we can change AC by replacing it with time t. So now we can say that acceleration is equals to final velocity minus initial velocity divided by time taken for the body to accelerate. In the right side of the equation, the time is being divided. In order to move it towards the left side, it will be multiplied. When time comes towards the left side of the equation, it becomes acceleration multiplied by time t. If we rearrange this equation, it means that if we bring the value of Vf, we bring initial velocity towards left side and its sign changes from minus towards positive sign. Get an equation for the final velocity, which is Vf is equals to Vi plus At. So this is the first equation of motion, and it applies only to bodies which are moving with constant acceleration. It means that their velocities are changing by the same amount every second. So if you are given initial velocity Vi and acceleration, which is constant, and you have been provided the time t during which the body has accelerated, and you are asked that what is the final velocity of the object, you can easily tell the final velocity of the object by using this equation, which is the initial velocity. Whatever the initial velocity of the object is, it can be 0 or it can be any value, and you have to add at, where a is a constant acceleration and the t is the time taken for the body to accelerate. So the first equation of motion is relating four things: final velocity, initial velocity, acceleration, and time t. So if someone asks you that what is the value of Vf minus Vi, it means that what do you get if you subtract the final velocity of the object with the initial velocity? What's the difference between final velocity and the initial velocity? The answer is always equals to at, which is acceleration, constant acceleration, times the time taken for the body to accelerate. This is the gain in the speed during the time t, and because of this change in speed, we can say that the body has accelerated, because the body is only accelerated when there is a change in velocity in a certain time t, and this acceleration is always constant. So as I said in the starting of this video, that initial velocity can also be replaced by u. So this first equation of motion can also be written as final velocity denoted by v, initial velocity denoted by u, plus at. A represents acceleration and t represents time. So now let's discuss that how the first equation of motion is represented in free fall motion. In free fall motion, objects travel with a constant acceleration. It is the same acceleration. In free fall motion, in the absence of air resistance, all the objects will fall with the same acceleration, regardless of their mass. If an object is heavy or lighter, it will fall with the same acceleration. It means that both the objects will have the same change in speed per time. And this same acceleration is the acceleration due to gravity. And the value of this constant acceleration, which is never ever changed, is 9.8 meters per second. So we can say that in free fall motion, the objects always have constant acceleration whose value is 9.8 meters per second squared. In free fall motion, Acceleration due to gravity is always constant, whose value is 9.8 meters per second and is always directed downward. Why we are talking about direction? Because we know that acceleration is a vector quantity. So if you throw two objects, one object is lighter and one object is heavier, both the objects will fall at the same time towards the ground. So the first equation of motion in this case will be the same, but the acceleration A is replaced by g. Here g is the acceleration due to gravity and its value is 9.8 meters per second every time. So now let's discuss some important points regarding the first equation of motion, which you have to remember. In first equation of motion, objects are always moving along a straight line. In these types of equation, objects always move along a straight line. It is a straight line motion. Acceleration is always constant. So in the first equation of motion, many vector quantities are discussed, such as displacement, velocity, acceleration. In the equation, we don't use the direction. We only use the magnitude, the physical numbers which are used. Only the numerical value of the vector quantity is considered. The direction is not considered. In order to show the direction of the vector quantity, positive and negative signs are usually used. So as we are using only magnitudes of the quantities, the direction of the vector quantities such as initial velocity and other quantities such as displacement are always taken as positive. So we can say that direction is not shown in the equation, only the magnitudes of the vector quantities are shown in the equation. If the question shows that the object was at rest, it means that the initial velocity is 0. If the object ends at rest, again the final velocity is 0. So we can say that at rest, the velocity is always 0. Also remember that when an object is in a free fall motion, it is having a constant acceleration and it has a value of 9.8 meter per second square. So for example, in a word problem or in a numerical value, you have been told that an object is falling in free fall motion and you have been given all the values, but you have not been given the value of the acceleration. So you have to know that its value is 9.8 meters per second square. And if you have not been told the initial velocity of the object, but you have been told that initially the object was at rest, so you should know that the initial velocity is 0. Whenever there is a change in the velocity of the object, there is acceleration. If the change in velocity is increasing, it means that the velocity of an object is increasing after time t. We can say that the object is accelerating. But if after some time t, the velocity of an object is decreasing, we can say that the object is decelerating. So if the object's velocity is increasing, the acceleration is always positive. But when an object is slowing down, it has a negative value for acceleration. So you must include this in your calculations. Also, whenever an object is thrown upwards, it's slowing down. It means that it is decelerating. So it is having a negative acceleration and it finally reaches a final velocity of 0 at the top of its path. So you also have to write negative value in the equation for acceleration of an object which is thrown upward. When the object is thrown upward, gravity always acts downward. Velocity will increase upward. At the peak point, at the highest point, the velocity will become 0. And when it's coming back, its velocity will again increase. So whenever an object is slowing down or it is moved upward, its acceleration is negative. Thanks for watching and I hope you found this video useful. This is a very important topic of physics and if you have any questions regarding any of the concepts, so you can comment in the comment section and I will reply as soon as possible. Thanks for watching and like, share and subscribe for more videos.